Hi, in this lesson we are going to write a simple program to check whether a given number is prime or not. Okay, so we are going to read a input from the user, then we will check whether it is prime number or not. Then accordingly we will print that it is a prime number or it is not a prime number. To write the algorithm we need to know what is the prime number in the first place. So a prime number is a natural number greater than 1. So the input should be greater than 1. Okay, so it should be greater than 1, and if it has no positive divisors other than 1 and itself, then it is a prime number. So we don't need to check for 1, we don't need to check for the user input number. For example, user has entered 11. So if it has any divisor between 2 and 10, then it is not a prime number, otherwise it is a prime number. So we just need to check from 2 to 10 if the user input is 11. Okay, and in this program we are going to use a method called trial division method. It is very inefficient, but for this program it will be sufficient. Otherwise we have to know many details to write a very efficient program. Okay, in this method we have to test whether the number is divisible or not from 2 to square root of 1 n. So if it is 121, so if the user input value is 121, we have to check whether it is divisible from 2 to square root of 121, that is 11. We don't need to go beyond 11 because a prime number will never have a divisor greater than square root of that number. So it is enough to test from 2 to square root of n. So let's go ahead and write that program. Okay, let's see what is already in place. So here we are reading a number, then we have a boolean variable to check, to keep track to know whether it is a prime number or not. So initially we are saying it's a prime number, and if you see here we are checking it and printing it. So if we don't do anything else, let's run it. What happens? So if I enter 12, it says prime number. So I am not checking for any divisor, right? So I am basically assuming it's a prime number and I am printing it's a prime number. Now I will write the program. I will write a for loop basically, and I need to check from 2, right? And I need to check till it is less than or equal to square root of input value, right? So input value, instead of finding the square root, I will divide it with I. So that will do, and I will increment I++. So here first thing I do is I'm going to print a message. We are checking whether that input number is divisible by whatever the current value of I is. If it is divisible, then the remainder will be 0. In this case we can say it is not a prime number because it is divisible by some number between 2 and square root of input value. Okay, this is all we need to do. We don't need to do anything. The moment we find any divisor, we will say it is false, it is not a prime number. Accordingly we will print the message. Let's run it again. So this time I will print 11. I will enter 11, and 11 is a prime number. I will enter 121. So it checked whether it is divisible by 2, 3, 4 and 11. Then it said 121 is not a prime number. Let me enter one more number, 110. Okay, I know this is a prime number. Let's see what is going to be the output. So it says it is a prime number. Okay, it checked till from 2 to 1000. Okay, and there is no divisor, so it is a prime number. Now let's check for a known number, 27. Okay, it checked with 2, 3, 4, 5 because the square root of 27 is greater than 5 but less than 6. So I don't need to go to 6. So I just need to check till 5. And 27 is not a prime number. But here when I divide it with 2, it is not divisible by 2. So at that time it is still a prime number. But the moment I know 27 is divisible by 3, I can come out of the for loop, right? I don't need to check with 4 and 5, because if there is one divisor, in this case 3, then it is already not a prime number. So I don't need to check with remaining numbers. So the best thing we can do is, the moment we know it is not a prime number, we can come out of this loop by executing break statement. So let's execute this again and we will give the same input. This case, the moment it knows it is divisible by 3, it is not checking from 4 and 5. It is coming out of loop and it is printing it is not a prime number. This is one good way of writing the program. We don't need to execute unnecessary steps. The moment we know it is not a prime number, we can come out of this loop, because the only purpose we are running this for loop is to make sure there is no divisor. If there is a divisor, come out of the loop and say it is not a prime number. Okay, so can we do without break? Yes, we can do. How can we do that? We are continuing this loop as long as this condition is true. So here I can simply write and is prime equal to true. I want to iterate in this loop as long as it is a prime number, right? So if we execute this statement again, this program again with 27, this time also the loop is terminated once we found out that 27 is divisible by 3. So we can do without break also, but break is a bit more readable. Whatever method you prefer, go for that. Whether use a break or explicitly mention you want to iterate this loop as long as is prime is true. Okay, can we do any other improvement? Let's run the program again and see if we can make any improvement. So we know this is not a prime number, right? Sorry, this is a prime number. This is a big number, but it is a prime number. Okay, so the program is working fine, but it is checking for every even and odd number. So if it is divisible by 316 or 314, it will be divisible by 2 also. So we don't need to check for all these even numbers, right? So if it is divisible by any of these even numbers, it is going to be divisible by 2 also. So we can change our logic. Basically we can start from 3, and instead of going one by one, we can increment the value by 2. So we will check for 3, 5, 7, 9. Okay, so if the user entered some even number, this is not going to check for that, this particular loop. So we have to check for even numbers ourselves, right? So this is a very easy one. All that we need to do is if it is divisible by 2, then it is not a prime number. Very simple. So let's execute the program again. So if you see here, we are only checking for odd numbers. So the number of iterations are half in this case. So previously we iterated for 1000 times, but in this case we iterated only 500 times. So this is one more improvement that we can do to our program. Okay, that is all about this program. We read an input, we assume or we make an assumption that it is a prime number. Then we run a loop with all possible numbers between 2 and square root of that particular input number. Then if there is any divisor, then immediately say it is not a prime number. Then we will check at the end for the boolean variable and we will print it. Please go through this program. If you have any questions, please write to me in comments. I will try to answer those questions. Thank you for watching this video. Please subscribe and share it with others.